to Density Practice Problems Part 2. Today we're just going to do more advanced problems in density. So question 1. You have an igneous rock with a volume of 15 centimeters cubed and a mass of 45 grams, and another sedimentary rock with a volume of 30 centimeters cubed and a mass of 60 grams. Which of the rocks is more dense and why? So how we can tackle this problem in here? We have to find the density for both rocks, so the density of the igneous rock and the density of the sedimentary rock. Then we compare the two densities and find which one is more dense. So let's get started. So as a reminder, we all know that D, which is the density, equals M over V. So if we want to find the density for the first rock, which is the igneous rock, it says here that igneous rock with a volume of 15 centimeters cubed. So this is the volume and the mass is 45. That's the mass. So if we just apply it into the equation, mass is 45 grams divided by the volume, which is 15 centimeters cubed. So if we just work it out in the calculator, 45 divided by 15, the answer would be 3.0. So you have to write in two significant figures, and don't forget the units, grams per centimeters cubed. So that would be the density for the igneous rock. Now, if we want to find the density for the sedimentary rock, again, D equals M over V. In the question itself, it says that the volume is 30 centimeter cubed and the mass is 60. So we just apply it into the equation, and the mass is 60 grams divided by 30 centimeters cubed, and the answer will be 2 grams per centimeters cubed. So now what we do, the question is asking which one is more dense. Is it the igneous rock or the sedimentary rock? So this is 2 and this is 3. So obviously rock 1, which is the igneous rock, is more dense. This is D1 and D2. We say that D1 is more dense than D2 because its density is obviously higher. Calculate the density of a 600 grams rectangular block. So that's the mass of the rectangular block, a length of 8 centimeters, width of 6 centimeters, and a height of 4.5 centimeters. So D equals mass over the volume. Now we need to find the density. We have the mass, but we don't have the volume. How can we find the volume? We have the measurements of this rectangular block. So if I were to draw this rectangular block here, so in here it has a length of 8 centimeters, so that's the measurement of the block. The width is 6 centimeters and the height is 4.5 centimeters. So we use those measurements to find the volume. So V is going to equals the length times the width times the height. So it will be 8 times 6 times 4.5. So 8 times 6 is 48 times 4.5 is 216 centimeters cubed. Why is it centimeters cubed? Because I have 3 measurements here. Each one of them is centimeters. So centimeters multiplied by centimeters multiplied by centimeter will be centimeters cubed. So D will be M, which is 600 grams, divided by the volume, which is 216 centimeters cubed. So D will equal to 600 divided by 216. The answer will be, after rounding, because we're gonna round to 3 significant figures, so it will be 2.78 grams per centimeters cubed. Calculate the mass of a solid metal block with a density of 2.6 grams per centimeters cubed, a width of 18 centimeter, length of 4 centimeter, and a height of 2.3. So D equals M over V. We've got the mass, we've got the density, and we don't have the mass. This is what we need to calculate, and we don't have the volume, but volume is easy to be found. Let's try and recall. V equals length multiplied by the width multiplied by the height. So it will equal to length 4 times 40 centimeter times 18 centimeters times 2.3. So the volume would be 4 times 18 times 2.3. The answer would be 165.6 centimeters cubed. However, we need to round it, so we look at 1, 2, 3. We need 3 significant figures, and we just look at this. 6 means that we need to round up the 5. So V would equals 166 centimeters cubed. Okay, the unknown here is the mass. So we can just rearrange the equation to be able to find the mass. We can either use the density triangle that we talked about last time, or we can just simply arrange it by multiplying both sides by V. So now we can cancel out the V. So the mass will equal to density times volume. So density is 2.6 grams per centimeters cubed times the volume, which is 166 centimeters cubed. Centimeters cancel out each other, so the answer would be 2.6 multiplied by 166, and then it would be 4. After rounding, it would be 432 grams. That's it. Now moving on to question 4. An irregular object with a mass of 180 grams, so that's the mass of the object, was dropped in a graduated cylinder. So here we have a graduated cylinder, and we have the irregular object that was dropped in the graduated cylinder. The initial water level here was 20 milliliter. And then the water level rose up to 45 milliliter. So the water level rose up and became 45 milliliter after the object was dropped inside. Okay, now what we need to find is the density. D equals M over V. We have the mass, but we don't have the volume. How can we find the volume in this case? And we don't have any measurements for that object. So what can we do is we look at the water levels. So V will equals to the final water level minus the initial water level. So V will equals to 45 milliliter, the final water level. We subtract it by the initial water level, which is 20 milliliter. So the final answer will be 25 milliliter. That's for the volume. If you noticed here, the volume is in milliliter because we're checking the water level. But if we want to get the volume of a solid object, we have to use a centimeter. So in here, 1 milliliter is equals to exactly 1 centimeters cubed. So they're exactly the same, but it depends. We use milliliter if we're measuring liquids, and we use centimeters cubed if we're measuring the volume of a solid object. So in that case, we're measuring the volume of a solid object, so the volume will be 25 centimeters cubed. So we apply this into our equation. So M will be 180 grams divided by the volume, which is 25 centimeters cubed. So the final answer, D, will be, after rounding up and everything, it will be 7.2 grams per centimeters cubed. Right, I hope this video was helpful. Please stay tuned for our density practice problems part 3. Thank you.